Hello and good day. First take at recording CO11, simplifying an expression with exponents when dividing by the same base. So last objective, CO10, we talked about multiplying by the same base. And I said that your clue to that rule was that you could see the multiplication symbol. What do you think your clue is for this rule that you're going to be dividing by the same base? So that when you see this, your brain goes to, okay, this is the rule that I need to use here. Alex? There's a fraction, right? And as we all know, the fraction, that fraction bar is the operation of division, okay? We are again going to start this out using expanded form, just so we can see what's really going on here. So the first one, 3 to the 5th divided by 3 squared. We've got our numerator, which is 3 to the 5th, 3 times 3 times 3 times 3 times 3. And we've got our denominator, just 3 squared, 3 times 3. Okay. Now, there's a method in my madness writing that 3 times 3 all the way over to the left like that, rather than centering my denominator. Why do you think I did that? What algebra rule do you know, have we worked with before, that is going to kind of help us simplify this here? William, what do you think? Okay. Sophie?
Opposite operations.
Not so much opposite operations here, because we're not really solving for a variable. Kylie? Yes, it has to do with canceling out, okay? In algebra, well, not just algebra, math, but anything divided by itself, whether it's a number or a variable or a root or whatever, anything divided by itself, except for 0, equals 1, right? So by putting my 3 times 3 over to the left and lining it up directly below my first two 3 times 3s in my numerator, I'm able to cancel those out. Okay, and what I'm left with are 3 3s in my numerator and nothing in my denominator. Okay, do I have to write my denominator since everything canceled out? No. If I wanted to, what would I put? Over 1, right? Not over 0, right? By canceling out, these each become a 1 because 3 divided by 3 is 1, not 0. Okay, but I don't have to write that. All right. Let's look at the next one here. 6x to the 4th z squared looks like this. 6 times x times x times x times x. That 6 is a coefficient, so there's only one of them. And then x to the 4th, and then times z and times z. My denominator, I'm going to line up my coefficient, my 3, with that 6 in the numerator. My x squareds, I'm going to line up with my x's, 2 of them, as many as I can. And my z cubes, I'm going to line up over beneath my z's. And I'm going to have actually one extra that kind of hangs out there a little bit. And again, the reason why I do that is because I want to be able to cancel some variables out here. Let's start with our basis of x. 2 x's from my numerator and my denominator cancel out, right? 2 z's from my numerator and my denominator cancel out. What about my 6 and my 3? What do I do with those? Noah? I don't multiply them together because this is a fraction, right? This does say 6 divided by 3. Aiden? Yeah. So the fraction 6/3 simplifies to be what? 2 over 1, which you don't have to write the 1 because it's in the denominator, but we can if we want to. Okay? So my simplified expression here, in my numerator, what do I've got left? I've got a 2, and I've got x times x, which is x squared. In my denominator, what do I have left? Just a z. Just a z. Okay? So that expression simplifies to be 2x squared over z. Last one, 9m to the 4th over 12m, my numerator. 9 times m times m times m times m. My denominator, 12 times m. What can I do? Who'd like to offer their wisdom? Crinkle.
Cross out one of the m's.
Yes, one of my m's cancels out.
Simplify 9.
Very good. Yeah. So 9 and 12 don't divide evenly like my 6 and 3 did. So instead of saying here we divide, 6 divided by 3, we're going to simplify 9/12. What does 9/12 simplify to be? And again, this is a fraction. So think about it just like a fraction. Kylie? 3/4. Okay. So what do I have left? In my numerator, I've got a 3 and m cubed, 3 m's remaining. In my denominator, I've got a 4. Right? That 4 coming from, that 3/4 coming from that 9/12. Okay? You would not want to divide 9 by 12 in your calculator and put 0.75, just because it's given to you as a fraction. We can write it as a fraction here. If you did write 0.75 m cubed, it would have the same value as what we have here, 3m cubed over 4. However, get used to writing answers in fraction form. Okay, we will use fractions more and more and more as we get deeper and deeper into algebra. Okay, now comes the fun part. What's our rule so we don't have to write this in expanded form all the time? What do we do with the coefficients? What do we do with the exponents? What do we do with the bases? Okay, kind of the same 3 things that we talked about in CO10. Ellen, give me one of them. Whichever one you want.
So you had like x to the 4th and x to the x squared at the bottom, you could subtract.
All right, so exponents are subtracted. Okay, exponents are subtracted. And I hope you can see why here, right? The reason why we can subtract the powers, in 3 to the 5th over 3 squared, because these 2 3's canceled out with 2 3's in my numerator, well, if I take 2 away from my 5, I've got 3 of them left. Okay, so powers are subtracted. Coefficients or our base. Alex, give me one of them. No. Our base is not divided by any opposite base. Kylie? Yes, coefficients are simplified. If you want to put divided, then you can. Since we're dividing by the same base, divide the coefficients. However, in like 9/12, we really didn't divide that. I mean, we kind of did, but we more simplified it. So simplified is what I'm going to put there. But if you want to put divide, then that works too. How about our base? Our bases, right? Our first one, we had a base of 3. What do we end with? A base of 3. We had bases of x and z. We ended with bases of x and z. We had a base of m in the third one. We ended with a base of m. So what happens to the bases? Stay the same. Just like in CO10. This is the rule. Simplified, subtracted, stay the same. Yeah. In geometry, SSS will stand for side, 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 but we're not there yet. For right now, it's simplified, subtracted, stay the same. Okay. How do you know? One more word on the exponents here. How do you know where to put your remaining bases? Since you have a fraction, you have a numerator, and you've got a denominator. How do you know where to put them? Max?
So, like for the first one, since the 3 has a higher exponent, you usually put it on the top.
Okay, good. What are you going to say? Well, I mean, we've got, like 2 z's here, 3 z's here. There's bases in both the numerator and the denominator. Here we have, 4 m's here, 1 m here. How do we know to put our z's in the denominator in that one and our m's in the numerator in that one? Aiden?
Because wherever the most of the bases is.
Yeah, we're going to have more to start with, right? If you start with more z's in your denominator, that's where they're going to be left because you couldn't cancel them all out, right? If you start with more m's in your numerator, that's where they're going to be left. Okay? Other questions on this? Yeah.
Most of the time it's the exponents for the numerator.
I suppose most of the time, yes, but really look at where do I have more? Where do I have more? Okay. Let's look at some stuff down below. This is, again, you're going to get a little bit annoyed with me because I am requiring you to write each expression in expanded form first, then simplify it to be one term.
What if you did a fraction?
What's that?
Does one term mean like right as a fraction?
Yes, yes, yes. So 9 to the 6 over 9 to the 4th in expanded form. 9 times 9 times 9 times 9 times 9 times 9. In my denominator, 9 times 9 times 9 times 9. What do I, now, writing this out in expanded form actually to me is kind of fun because now what do I get to do? Get to cancel a bunch of stuff out. Like Fruit Ninja, but math. Okay? And so what we're left with, in my numerator, I've got 2 9s, which we write as 9 squared, right? In my denominator, I've got nothing left. So I don't have to write it. 9 squared would be an acceptable answer here. But if you wanted to, 9 squared over 1 is what you'd put. Okay? What do you think the most common wrong answer is to a question such as this one? William?
You multiply?
No, not multiply. Sorry? Put a 0 in the denominator. I have seen that before. I have seen the multiplying too, but the most common, Catherine? 9 times, oh yeah, just put 18 down. That's a no-no. I have seen that before too. That's not the most common. Ellen? If you did put 81, that wouldn't be wrong. I mean, 9 squared is 81. So I would not take point off for that. No. Andrew? No, although I've seen that before. No, the most common wrong answer to this, someone would put 1 squared. Where do you think they would get that 1 from? Claire?
They subtracted it, and they just looked at it, and they did 9 minus 9, and then 6.
Not minus 9, but they treated these 9s as coefficients instead of bases, right? So they took 9 divided by 9 to get 1 and then subtracted the powers. This is why expanded form really helps with that. When you see it in expanded form, this answer looks ridiculous, right? How would you get a 1 squared from what we have here? But it just looking at it, if you're going too quickly, you say, oh, okay, 2 divided by 2 is 1, subtract the powers, 1 to the 5th, right? But no, those are bases. The base stays the same. The coefficients, we get simplified, but we're not dealing with coefficients. So don't do that is the moral of that story, I guess. C to the 5th over c squared. Let's see here. C times c times c times c times c over c times c. I wish Long John was here. I got a pirate joke for you. What is a pirate's favorite letter?
R.
You'd think it'd be R, but it's the C. Anyway, now that we get to cancel those out, we see we've got c cubed, 3 c's left up in the numerator, nothing in the denominator, so c cubed would be a perfectly acceptable answer. If you want to put over 1, that's fine too. 2 to the 8th over 2 cubed. Again, expanded form is required, so we're going to write out our 8 2's over our 2 times 2 times 2. Now we get cancel happy. Get to eliminate, cancel out 3 of them because anything divided by itself is 1. And we're left with 2 to the 5th power in our numerator. Okay? Next one, h to the 5th over h to the 7th. So this is one where we've got more h's, more of our base in the denominator. Okay? So when we go to our canceling here, in expanded form, it's very easy to see where our leftover h's are. Okay? They're in the denominator. Do we have to write a numerator here? Can I just put h squared? No. Denominators, if everything cancels out, they're optional. Numerators, if everything cancels out, they're not optional because you have to show that these 2 h's are in the denominator of your fraction. So what do I make my numerator?
1.
Good. Not 0, not an h. All the h's are gone. We're left with a 1. Okay, so 1 over h squared. How are we doing so far? Sit flat, please. Okay. Let's go over, might as well let's go over the next two on this page. If you've already moved on to the second page, you'll see that I don't require expanded form anymore. So really, okay. Once we show we can do it with expanded form, we eventually want to move to that rule because it is much more efficient. Especially when I make exponents like this. My goodness. Okay. Yeah, right? Yeah. Whenever you say I'm mean, just remember I could make you write that in expanded form. So my coefficients here, 8 and 4, 8 fourths simplifies to be 2 over 1. Works out evenly. My x's cancel out every pair that I can. I see I've got one x left in my denominator. My y's, everything in my numerator cancels out. I've got 2 of them left. So this one simplifies pretty well here. 2 left in my numerator. That's it. And then xy squared in my denominator. And there we have it. 2 over xy squared. Any issues with seeing any of this stuff? Any of you lost? Not quite sure how to deal with this or that? All right. Last one on this page. 10xy squared over y to the fourth. Expanded form. 10 times x times y times y. Denominator. Y times y times y times y. The only thing I can cancel out are my y's there. So 10x in my numerator, y squared in my denominator. Very Christmassy today. Any questions on this? Okay. Yes, Anthony.
I'm having trouble with the first problem on the back.
All right. Nothing else on the front page?
Nope.
Or first page? Okay. Let's look at the second page. And this will be your homework due tomorrow. Looking at that first one, it says simplify each expression. The goal here is to not have to write the expression in expanded form. However, if you're finding that you're getting a lot of these wrong, then you might want to, just until you really get a handle on it. Anthony, what is your question on this first one?
I don't really know.
So if you remember the rule, the coefficients are simplified, exponents are subtracted, base stays the same. So part of this is identifying what are my coefficients, what's my base, what are my powers. What are the coefficients here?
5 and 10.
5 and 10. So this fraction 5/10 is going to be simplified. What does 5/10 simplify to be? 1/2. So I'm going to start my answer here with a 1 over 2. I want to leave a little bit of extra room there because I'm going to be writing a base somewhere, right? So then you look at your exponents, and you've got a 6 and a 3. Okay? How many n's will I have left, and where will they go?
3 and 30.
All right. Sounds like you understand that quite well there. Okay? That's it. That's your final answer. Okay? Ellen?
Could you not do the 1?
Yes, if you just wanted to write this as n cubed over 2, that would be fine. Claire, was that your answer too?
Yeah.
Glad I could clarify. Any others on this page you want to talk about? Oh, you got to stand. Catherine. Third row, last one. All right. Let's see what we got here. Ooh, my goodness. Okay. So this one is where we kind of start to introduce having to do more than one thing, right? We've got a fraction here, but we've got stuff going on, okay? So the nice part about a fraction is that you can deal with them, the numerator and the denominator separately, right? We don't have to do the whole thing at once yet. Just looking at our numerator, what does that simplify to be? just look at, and this goes back to CO10 now, right? But looking at the numerator, what does that simplify to be? Max?
-36 times n to the 14th.
Negative 48 times n to the 14th. Okay? I'm multiplying by the same base in my numerator, so my coefficients are multiplied, my exponents are now added. In my denominator, what does that become? What does that become? Noah? Negative 36 n to the 6th. Coefficients multiplied, negative 9 times 4. Exponents added. Okay? Now that I've simplified my numerator and simplified my denominator, now I can look at the fraction as a whole. Right? I've got coefficients of negative 48 and negative 36. What does that fraction simplify to be? Obviously, it's going to be positive because, negative signs cancel out. But 48 36ths, what does that simplify to be? Yeah. You said, sorry? Okay. Joey? 4 over 3. We can divide both by 12, which gives us 4/3. And then how many n's and where are they? How many n's and where are they? Catherine? N to the 8th in the numerator. So 4 n to the 8th over 3. Yeah, that's a good one. Yes. So the last row here, it's kind of like Jeopardy, where I give you the answer and you give me the question, so to speak. So it says, write an expression that would simplify to be the following. So if I give you x to the 12th, that's what I want the answer to be. Give me an expression that would simplify to get us there. Aiden.
Can I answer the bottom one that you asked the question for just now?
Yes.
X to the 100th times y to the 10th in the numerator, and in the denominator, x to the 88th, and then y to the 10th.
So if you start with,
I just did x to
some people like to be a little bit fancy. That's all right. If you start with this expression and I were to simplify it, I'd say, okay, 100 minus 88 gives me x to the 12th in my numerator. My y to the 10th over y to the 10th, they all cancel out. Anything divided by itself is the exact same thing. So I would be left with x to the 12th. This would be a correct answer. What someone else said, just x to the 13th over x, that would also work, right? That would also simplify to be x to the 12th, okay? So for each of these, you can be as creative or as lame as you want to. But give me an expression that would simplify to be what I have there. And just as a heads up, one of your test questions on a few objectives is this, where I give you a final answer and you have to write an expression that simplifies to be that. So this is kind of practice for the test. You will have to do this on the test. Yes?
For the third one on the bottom, can you just rewrite that as it is, because that can be the problem?
No, you can't just rewrite the answer as your original expression. When I said be lame, I didn't mean be like lame, like the lamest of the lame. It is, but I don't want you to have fun. All right. Any questions, comments, concerns, complaints, comments, congratulations, criticisms? Arlene. Because one of our rules for division is a negative divided by a negative is a positive. So since they're both negative, then when you divide them, it would cancel out. Folks, anything else? All right, this is homework, CO11 homework due tomorrow. The whole page, the whole objective, that is how you math.